So in the polar coordinate system, because we're dealing with a circular coordinate system, any point on here can be represented an infinite number of ways because we can keep traveling around the circle. But and that's different from a point in our rectangular coordinate system. So what we're going to do in this video is look at, if I'm given a point in this coordinate system, can I come up with 3 different ways to represent that same point? So here I have my graph drawn over here, and I want to find 3 other ways to represent the point 5 pi over 4. Let's start by just plotting this point on the graph. So if I have, if I have the point 5 pi over 4, then that means I have rotated pi over 4 and come out of the pole a distance of 5, which would be right here. So what I'm trying to do in this video is find 3 more ways to represent, in other words, 3 coordinates that would represent this exact same position on my graph. The first one's fairly easy. The first one says I need r to be positive, and I want a theta then that is between 2 and 4 pi. So if theta is between 2 and 4 pi, then that means that I have traveled 1 time plus more around the circle, right? So if I'm starting originally at this point, right, because this is the point we're going to represent multiple ways. If I have this point here and I travel all the way around the circle 1 more time and come back to that point, I've traveled a distance of 2 pi. And because we are talking about theta now, right, so I've gone around 2 pi plus pi over 4 would be 9 pi over 4. So let's just put theta down as it is right now. And because I have traveled this far from theta is this, r is still that same distance 5 out from the pole. So the point 9 pi over 4 is another representation, so we are still back here, is another representation of the original point we started with. Now let's look at the next representation we're being asked to find. This time I want r to be negative, and I want theta to be between 0 and 2 pi. Okay, so if r is negative, remember that when r is negative, I first rotate theta and then shoot in the opposite direction of where I landed. Okay, so I'm first going to rotate theta and then move in the opposite direction to get a negative r. If this is the point I need to come back to, then if I were to rotate, let's say I rotate all the way down here to 5 pi over 4. Okay, so I'm at here. That's theta. Then if I shoot back in the opposite direction, right, from the pole, if I were to shoot in the opposite direction, I would be right back here at my original point. So the idea for this is that I'm first going to rotate theta, it looks to me like 180 degrees away from, or pi radians away from my original point. And then because I need a negative r, I'm going to shoot back in the opposite direction of where my theta was, and I land right back on 5 and pi over 4. So let's talk about what this point would give us. Theta in this case is 5 pi over 4. So we have 5 pi over 4 for theta, and then negative 5 for r. Okay, so the negative, r negative of this point right here says I'm going to move theta, which is really 180 degrees away from where I started, and then shoot back in the opposite direction. That one's the most difficult of them all. The last point I want to represent says I want r to be positive, so I'm going to shoot out of the pole in the same direction I'm rotating, which is good. But this time I need theta to be between negative 2 pi and 0. So if I need theta to be negative, between negative 2 pi and 0, that's really just saying I'm moving in a negative degree or a negative radian measure. So if I start here on my polar axis and I rotate all the way around back to the point I started with, okay, so I'm back here at this point, how far have I rotated? So if I'm moving in this direction here, hopefully you're going to say that that is negative 7 pi over 4. So if I rotate, there's theta, and I need a positive r, so I'm going to move out from the pole 5. This is the third representation of my original point, 5 pi over 4. So you can see that there's multiple ways to represent the point. These are just 3 different ways that we can do it.